Hello everyone, this is the problem related to V belt drive. Uh, so I have discussed already about the theory part regarding the V belt drive. So we will see a problem regarding the V belt drive. So V belt drive, the first thing that we have to do while solving the V belt drive is we need to select a proper belt. Okay, so as the belts V belt drives are designed based on the power capacity, that is A, B, C, D and E, so that we have to select it based on the power to be transmitted. Okay, so see here, first thing that we have to do is from the given power we have to select a belt that will be suited for the given power. Okay, so here in the data book page number 24.3 you can find the data related to V belt drive. So 24.1 types of V belts and the standard dimensions. Here the cross section symbols, that is A, B, C, D and E. So you can see the load. Okay, load that is acting, that is power to be transmitted, that is 0.5 to 5, 2 to 15, 7.5 to 75, 22 to 150 and 30 to 190. So here the belts that suits is C, D and E. Okay, so C, D and E. So for my convenience I am we can select either D or E, because it lies between these two conditions, as it is almost at the end. So I am going to select either two of any one of them. Okay, D or E. So I am going to select the belt D. Okay, for the given power of 75 kilowatt, D type or E type belts are suited. So let us select D type belt. So after selecting the D type belt, so we have to calculate the design power. So the design power, why should we calculate the design power? Because we have to calculate the design power based on the, as we need to transmit the power. So power, you can see the formula here, design power. So whenever you are designing a belt, just keep in mind we have always we have to design for more capacity belts. Okay, so మనకి ఇచ్చిన పవర్ కన్నా మోర్ కెపాసిటీ బెల్ట్స్ డిజైన్ చేయడం వల్ల ఏంటంటే, బికాస్ ఆఫ్ సో మెనీ ఎక్స్టర్నల్ ఫ్యాక్టర్స్ లైక్ loading conditions, or because of pitch lengths, and because of every deflections there is a chance of power variations. So that's why we have to design the belt for more capacity than it is required. Okay, so the design power formula is PD is equal to PR into KS by KA into KL. So here PR is nothing but the power to be transmitted into KS. KS is nothing but your correction factor for industrial services. So in the page number 24.3 you can find the correction factor for industrial services KS. So you can select the correction factor based on the type of driving unit or type of driven machines or service of the severity of the services. Okay, so if in the question they have mentioned the type of driving units or driven units, you can select from them, or else you have to select from the severity of services. Okay, so in the question they didn't mention us the type of driving or driven, so only he has mentioned the service life. So here you can see the up to 10 hours, over 10 hours to 16 hours, over 16 hours to continuous service up to 10 hours, like this there is a thing. Okay, so light duty, medium duty and heavy duty and extra heavy duty. So keep in mind, go for, if nothing is there, just go for an assumption like heavy duty. So heavy duty we are going to select heavy. I am going to select heavy duty. Later the service life that he has given is over 16 hours of continuous life. Okay, over 6 10 to 16 hours the service is given as 10 to 16 hours. So which type of driving unit that we have to decide. So AC motors with normal torque or AC motors with high torque. So that he didn't mention us in the question, so I am going to assume it as AC motors with high torque. Okay, so you can assume anything because in the question he didn't mention us anything. That's why I am going for AC motor with high torque. Okay, so I am going to select as 1.5. Okay, so Ks value is 1.5. So the next thing that you need to select is Ka. So for selecting the Ka is nothing but correction factor for arc of contact. So we need to find out first arc of contact angle, and later based on the arc of contact angle we will be selecting the correction factor. Okay, so the correction factor we are having two things. One is VV belt and V flat belt. So VV belt means we will be having a trapezium section only. So VV belt will be like this, and V flat belt means it will be like this. Okay, so like that we have to select. Okay, based on that we will be selecting the arc of contact factor. Later we need to select the KL is nothing but your nominal here. So nominal correction factor KL. So nominal inside length, nominal pitch length, and correction factor. So based on the pitch length, so we have to select the correction factor. So we will be selecting the type of belt. So based on the type of belt length, pitch length, we will be selecting the correction factor length. Okay, so this is how we have to select the values from the data book. Okay, we will start the problem. So the design power PD is equal to P into Ks by Ka into Kl. Okay, so the Ks is nothing but correction factor. So the correction factor that we have selected is 1.5 for heavy duty. 1.5. So next we have to select the Ka, that is arc of contact factor. So the arc of contact. So arc of contact we have to find out the arc of contact, that is 180 minus d by t c into 60 degrees. So we are having speed of driving wheel, that is n value, that is the small n value. Speed of driven wheel, capital N value, small n value, capital N value, and diameter of the driving wheel we are having, that is the small d. Okay, so we are having only these conditions, but we don't have the diameter of the driven wheel. Okay, that is the capital D. So for finding the capital D, we have the formula capital D is equal to N by capital N into small d. Okay, so capital D we have to find out, that is the diameter of the driven wheel. Okay, 440 by 400 into 300. So we can find out the capital D. So the value that I have got is 1080 mm. Later we have to substitute the values in the given formula. Theta is equal to 180 minus capital D is 1080 minus 300 by service factor, that is center distance, that is 2500 into 60 degrees. So the value will be the value that we are going to get will be in degrees, that is 161.3 degrees. Okay, so after getting the value, that is theta value, we have to select the correction factor. So the correction factor that we have got is 160 degrees, almost 163. Okay, so the value will be lies between these two values. Okay, so whether we are selecting VV belt or V flat belt, okay, based on that we will be getting the value. So I'm going to select as 0.995. okay, so that means I'm going to select the VV belt, that is 0.95. 0.95. okay, so K value, so later we have to find out the KL value. So the KL value can be found out by pitch length. Okay, so for finding the pitch length we have to find out the length of the belt. So the length of the belt can be calculated by the formula of open belt drive. So open belt drive formula that we have to know, so that can be found out in the flat belt drive table. So see here, L is equal to 2C plus pi by 2, 2C plus pi by 2, D plus D plus capital D minus small d by 4C in square, 2 into 2500 plus pi by 2, the 1080 plus 300 plus 1080 minus 300 square by 4 into 2500. So we will be getting the length value. Okay, so we are going to get the length value with this. Just try to calculate and tell me the answer. Okay, so I have got an answer of 7229 mm. Okay, so that is the pitch length that I have got. So based on this pitch length I am going to select the correction factor. So that I am going to get it from the page number 24.6, table number 24.4. okay, so based on the nominal pitch length, so I have selected the D type of belt. So D type of belt, just try to see the value that we have got. So I have got an answer of 7229. So that is the nearest value that we are having. So I have got as 7648, that is the standard value. Okay, so we don't have other value here, that's why we are going to select this as a standard value, and this is the corresponding inside length. Okay, so inside length, nominal inside length, that is the corresponding inside length, and this is the pitch value. Okay, so the cross sectional value, so this is the standard length. So we are going to select these two, and based on this we are going to select the correction factor. So I have selected based on the D, the correction factor is 1.05. okay, so see here, the next standard pitch length is equal to 7648. 7648 mm, corresponding inside length is equal to, that I have got is 7569. Okay, so correction factor KL is equal to 1.05. Okay, so I have got all the things for calculation of design power. Okay, so power that the question power that I have given is 75 kilowatts. 75 into Ks value is 1.5, KL value is 1.05, Ka value is 0.95. Okay, so I am going to get the design power value. So I have got an answer of 112.0 kilowatts. Okay, so this is the design power that I have got. So based on the design power, so the maximum power in kilowatts which the V belt of the sections A, B, C, D and E can transmit shall be calculated by the following formula, that is in the page number 24.8. Okay, so we'll be having the belt cross sections here. So based on this formula we are going to select the power rating of a belt. Okay, so power rating of belt, that power rating of the belt, so whatever the power rating that we get should not be over, so we need to calculate the power rating of a belt. Okay, so the maximum power in kilowatts which the V belt can be transmit shall be calculated by using that formula. Okay, so I have selected the D belt. So D is belt power rating, for D type belt. Okay, so PS is equal to 3.22 V power 0.09 minus 506.7 by DE minus 4.78 into 10 to the power of minus 4 V square into V. Okay, so this is the formula we are having. Sorry, I have congested that formula here, so I don't want to congest here. So let me write the formula once again. PS is equal to 3.22 V power 0.09 minus 506.7 by DE 4.78 into 10 to the power of minus 4 V square into V. Okay, so this is the formula. So here V is nothing but your belt speed, that is in meters per second, and D is nothing but equivalent pitch diameter. So equivalent pitch diameter can be found out by DE is equal to D into KD. Okay, so see here, D is equal to D into KD. Okay, D is nothing but the pitch diameter of this small pulley, and KD is the small diameter factor account for variation of the arc of contact from tables below. Okay, so you can find the KD value here. So speed, based on the speed ratio we can find the KD value. Okay, so KD value that we need to multiply with the pitch diameter of the smaller pulley. Okay, so the KD value can be found out by D by D ratio. So D by D ratio that I have got, that I am going to get is 3.6. Okay, so 3.6, which is over 2.949, and over we have to take the value of 1.14. So the KD value is 1.14. So we have to multiply that value, D value. So the D value is nothing but 300 into 1.14. So I have got an answer of 342 mm. Okay, so see here, so the maximum value of D in the formula, that should be not more than 425. Okay, so if it is more than, means we have to change everything. Okay, so I have got is 342. Okay, so which is less than the maximum value, so that's why our design is safe. So then we have to calculate the V value. So V is the belt velocity. So the belt velocity V is equal to pi dn by 60 into 1000 meters per second. Okay, so pi into 300 into n value is 1440 rpm by 60 into 1000. Okay, so we will be getting an answer of 22.6 meters per second. Okay, so this is the value that I have got. So later we have to substitute those values in the given formula. Okay, so PS is equal to 3.22 into V value is 22.6 power 0.09 minus 506.7 by D value is 342 minus 4.78 into 10 to the power of minus 4 into 22.6 square into 22.6. So just do the calculation and tell me the power transmitting capacity of a one belt. Okay, so I have got an answer of 15.96 kilowatts, that is for 180 degrees of arc of contact. Okay, so that I have got. But what is the arc of contact value that we have got is 161.3. Okay, so we have to do the calculations for 161.3 degrees. So required belt capacity for 161.3 degrees arc of contact. So that is 15.96 for 161.180. So I have got an answer of 14.3 kilowatts. Okay, so this is the required belt capacity for 161.3 degrees of arc of contact. Now we have to find the number of belts. So the number of belts can be found out by the formula. So number of belts can be found out by the formula I is equal to PD by PS. So that is design power by belt rating. Okay, so the belt rating that we have got is 14.3. Okay, that is the belt capacity. Okay, so I is equal to design power. So the design power that I have got is 112.0 by 14.3. So I have got an answer of 7.82. So we are having around 8 belts. Okay, so number of belts we are having is 8 belts. Okay, that is equal to R. So you have observed that we have taken the next standard pitch length. So suppose this is the belt. Okay, so this is the pitch length. Okay, so pitch length, this is the pitch length. So first that we have got is 7229, that is the length, but we have selected for next standard pitch length. So obviously if the size of the belt is increased between the pulleys, okay, so if the size of the belt is increased, obviously we have to adjust the center distance. Okay, so there we must change the center distance. In order to calculate the center distance, C is equal to A plus root over A square minus B. So A value and B value can be found out by these two formulas. Okay, C is equal to A plus root over A square minus B. A is equal to L by 4 minus D plus B by 8. So now L is nothing but your next standard length, that is 7648 by 4 minus pi. Capital D that we have got is 1080 plus 300 by 8. Okay, so what is the answer that we have got is 1370. And for calculating the B, we are having the formula of D minus D by 8. So we will be getting the value of B here, 76050. C is equal to 1370 plus root over 1370 minus 76050. Okay, so center distance that we have got is 2712. Okay, so that is the value that we have to change. Okay, so what is the actual center distance? That is 2500. Okay, so what is the change center distance? That is 2712. Okay, so the next step that we have to do is we have to find the initial tension. So in order to give the initial tension, the belt may be stretched 0.5% to 1% of its length ending. Okay, so what is the length we are having? 2712, and that initial tension will lies between 0.5 to 1%. So that's why I am going to select as 1% of its length. You can select any of the thing. So take 1% of length. So what is the standard that we have taken? 7648 into 1 by 100. So I have got an answer of 76 mm. So that we need to add for the final center distance. Okay, final center distance 2712 plus 76. Okay, is equal to, so we have got an answer of 2788. Okay, so this is the final center distance. Okay, so later we have to find the width of the pulley. So width of the pulley, so you can find the tabular column here. So based on this tabular column we have to find out the width of the pulley. So width of the pulley is equal to width of pulley, that is equal to r minus 1 e plus 2 into f. Okay, here is number of belts, e is the center to center distance of grooves. Okay, so that we have selected based on the type of belt that we have selected. Okay, and f is the edge of pulley to first groove center. Okay, so substitute those values and you can find out the width of the pulley. Okay, that's the end of your problem.